So I welcome all the participants to our second keynote by Professor Cho from Yonsei University, South Korea. So I request Professor Sudhakar sir to introduce him. Sir, please.
Thank you, sir. It's my privilege to introduce Professor Sung-Bae, professor in Yonsei University, South Korea. Dr. Cho received the BS degree in computer science from Yonsei University, Seoul, Korea, and the MS and PhD degrees in computer science from KAIST, Korea Advanced Institute of Science and Technology, Daejeon, Korea. He was an invited researcher of Human Information Processing Research Laboratories at ATR, Advanced Telecommunications Research Institute, Kyoto, Japan from 1993 to 1995, and a visiting scholar at University of New South Wales, Canberra, Australia in 1998. He was also a visiting professor at University of British Columbia, Vancouver, Canada from 2005 to 2006 and at King Mongkut's University of Technology at Thonburi, Bangkok, Thailand in 2013. Since 1995, he has been a professor in the Department of Computer Science, Yonsei University, and an Underwood Distinguished Professor from 2021. His research interests include neural networks, pattern recognition, intelligent man-machine interfaces, evolutionary computation, and artificial life. He was the recipient of the Richard E. Mervyn Prize from the IEEE Computer Society in 1993. He received several distinguished investigator awards from Korea Information Science Society in 2005 and Gohyeong Shindoriko in 2017. He is also a recipient of Service Merit Medal from Korean government in 2022. He has published over 230 journal papers and over 680 conference papers. According to Google Scholar, total citations are 17,000 plus and H-index is 60 and I-10 index is 279. Now, may I request Professor Cho to deliver the talk, expert talk. Thank you, sir.
Thank you very much, Professor Sudhakar. I have never imagined that you read all the biographies that I gave you. Anyway, thank you so much. And hi, everyone. I guess you are just in the before noon, so you must be quite hungry. Now, I'm in Korea. Now the time is already 2:45. So, you know, the time difference is a little bit significant. I already had my lunch. So anyway, I'm glad to be here to share some of my experience on research with all of you. And I was told that your conference is on computing, communication, and learning. And I looked over the program, and there are quite many interesting papers presented here. So maybe my talk is quite basic or not that relevant to what you are interested in. But basically, I would like to remind you the change of the computing with artificial intelligence, especially machine learning. I don't know in India maybe, but I guess near the same to Korea. And Korea has been changing the research direction significantly during the past 6 to 7 years. Maybe with the event of AlphaGo in Korea, 2016. And many people just realized the power of artificial intelligence. And it can give us some promising future to revolution. So I would like to share some of my research regarding to that direction. So the title is a little bit ambitious, but basically I would like to share my viewpoint on computing and the current research work regarding the deep learning. the generally, I'm not sure how many people are aware of neural networks and deep learning, so I will briefly introduce the basic idea, especially from my point of view, and introduce an idea to exploit or utilize the internal variables inside of the neural networks trained with deep learning for practical applications in computing. So today I will explain about the case studies in 3 different problems in cybersecurity and another computer security and energy prediction problems. So we are just expert in computer, right? So what is the computer? Computer is sort of the machine to produce appropriate outcome in accordance with the input from the environment. And usually the mechanism of computer is doing with sequence of command. So as a software engineer or computer scientist, we have to devise the algorithm. Means that a sequence of the command which can produce the appropriate output from the input. However, there are so many problems that we cannot solve with this idea of computing. You know, the computing is already proved in some sense with the Turing charge thesis or some other theoretical ones. But still, there are so many intractable problems that we cannot work out with this mechanism. So in artificial intelligence, we would like to use many different disciplines like logic, rule, probability, etc. A lot of things are possible to devise sort of the algorithms. However, whatever algorithms we devise with these materials, we cannot prove, we cannot succeed in some sense. So anyway, we know the problem. We know the problem to produce appropriate output Y with the appropriate input X. Then even though we cannot devise the absolute sequence of the command, we can just make use of the set of the parameters. And if those parameters are appropriately adjusted with some algorithm, then anyway, we can solve the problem. That is now the basic idea of neural networks and artificial, the deep learning actually. So for example, our problem means that environment can give us a sort of the picture like this. And finally, we would like to decide which is which. Actually, there are a cat and a dog. How can it differentiate those 2 animals? So originally, the artificial intelligence tried to describe or represent the characteristics of dog with some specific appearance or behavior, etc. And also at the same time, we would like to represent the characteristics of cat with appearance, behavior, etc. And try to differentiate those objects. However, still, there are so many different kinds of dogs and cats and with different shapes and different postures. So it is quite difficult. So by using the neural networks, maybe we can just make some model to differentiate the space of dogs and space of cats. So in some sense, it is quite easy to get the solution if we have a lot of data. That is sort of the new direction of computing. Then that kind of idea is called as machine learning. So you actually, I can see that one session is called learning. So most of you are already aware of what machine learning is. However, from my point of view, that machine learning deals with data composed of many different attributes. Actually, the data cannot be restricted with tabular form, but anyway, the images, sound, or sensory information, any kind of data can be reformulated with a vector with many different attributes. So machine learning tries to construct a model for classification or prediction. Actually, the classification or prediction are so limited problem from the computing point of view. However, just think about any problem that can be solved by computer can be reformulated as classification or prediction problem. And most important point is that we do not want to construct an accurate model with the given data. So what you want to do is to produce some model which can output the collect result for the future unseen data. So anyway, we do not use all the data to construct the model. So anyway, even though the data set is not enough, we try to divide whole data into training and testing. Actually, that is quite important concept in machine learning. And there are so many different kind of algorithms to construct the models, from k-nearest neighbor to multi-layer perceptron. And now, today, I would like to focus on multi-layer perceptron because it is just the typical shape of the deep learning model. Then, anyway, in neural network, what is it? Actually, neural network is also quite a complicated concept. It is a computational model of the human brain. And human brain is composed of a massive number of neurons. Of course, the neuron itself is also quite complicated. However, simply saying, one neuron can produce the output from the weighted summation of the input. Actually, all the line have that weight, different weight. So weighted summation of the value should be produced after nonlinear function. So those simple computational unit can be used to construct a neural network like this. So usually we arrange the neurons in layer-wise like this. Here, there's only one hidden layer, but depending on the complexity of the problem, we can use more than one hidden layers. So anyway, by constructing this model, what we expect is to decide that correct weight, which can function properly to produce appropriate output against the input, right? And if we increase the number of layers, then we can get sort of the complicated deep neural networks. That previously, it was the big headache in the field of neural networks and artificial intelligence to devise some algorithm which can work to decide the appropriate weight in the neural network with many hidden layers. Usually, we used only one hidden layer. However, depending on the complexity of the problem, sometimes we need to use more than one hidden layers. So just to think about this problem from the mathematical way, our final goal is to construct a function which produces the appropriate output y to the given input x. Then maybe if we can use many functions sequentially, then by composing those functions, we can construct quite complicated function, right? So anyway, in real-world problems, anyway, we need many functions. Here, the many layers. There was a big headache in the field of neural networks, and finally, we succeeded with many different algorithms called deep learning. So there are many different models, right? However, I can dare to say there are only 3 distinctive models which can be used for practical applications. They're here or there. Most of the problems regarding the image or some static data set, then maybe we can use this kind of neural network called convolutional neural network. And if we have to solve the problem related with the time sequences, then maybe we'd better to use the recurrent neural networks. By the success of these two models, there are a lot of interesting models. Inception, ResNet, DenseNet, encoder, decoder, attention, and even nowadays, we do not use the recurrent connection for recurrent neural network with attention additional parameters called the transformer model. So anyway, these two are the basic models for the application. And in between, another interesting model called Generative Adversarial Network came up a little bit recently. Mostly this architecture can be used for generative problems. So convolutional neural network is the typical feed-forward neural network with a little bit specialized connectivity with the convolution, nonlinearity, and pooling or subsampling. And by arranging those layers again and again, we can construct quite deep neural networks. And if we have a lot of data, anyway, we can construct that neural network with appropriate weight with backpropagation. Actually, this algorithm is the key for any deep learning models. So with this model, we can achieve quite interesting applications like object detection and recognition, especially for autonomous car, autonomous vehicle. Maybe we need to understand the current situation as quickly as possible. So the autonomous car should decide the object is ahead of the car should be the car or passengers or the traffic signals, etc. Those things are now possible with the convolutional neural networks. And for the recurrent neural network, it is also another simple neural network with feed-forward style. The only difference is that inside of hidden layer, each neuron inside of the hidden layer has the self loop, which can store or remember the previous information about the data set. Then this data set, this model can usually work quite well for the language processing. For example, the machine translation from Korean to English, or text summarization from the long text to the abstract, or reading comprehension to give the correct answer for the question with a short text. Actually, that is quite a difficult problem to understand. However, nowadays, with the power of deep learning, we can get a lot of interesting success. And third model is generative adversarial network. It is a little bit interesting, more interesting. Actually, previous two models were invented more than 30 to 40 years ago. However, this model is brand new. About 6 to 7 years ago, the Ian Goodfellow proposed this model. Actually, this network is composed of two neural networks as pair: generator neural network and discriminator neural network. So generator tries to produce the data, which is as similar as possible to the real data, and the discriminator network is trained to discriminate anyway from the fake data and real data. Those two networks are trained adversarially and reciprocally, so improve each other. And finally, this kind of model can produce the interesting images like this. It is just faces, quite many faces over here. It looks quite interesting. However, there is no real face. It is just generated once with the GAN model. And this kind of idea can be used for design or image transformation from that sketchy to real image, or black and white grayscale image to color image, or the picture in daytime to picture in nighttime, or some sketchy to the real mockup of the bag. That is quite interesting and useful. And maybe some of you already see this kind of example.
Moving forward, we need to be more vigilant.
There are quite interesting videos, and these videos are fake. It was not real. It was just made with the generative adversarial network. However, it is so realistic, right? So many people just confused about the reality of this kind of images. There is also quite powerful example. Nowadays, however, each model, of course, that we can use each model to solve some problems. However, just to think about each model is sort of the function, mapping function from input to output. Then maybe we can construct a more complicated model function with many different models as sub-functions, like mathematical composition. So that is called the hybrid deep learning. So this is my proposal, actually. So anyway, we can use the autoencoder or encoder decoder architecture like this. Especially, we can set the input and output as the same. Then maybe there's the functionality of this kind of network is nothing. However, you can extract some interesting features inside of the data in the internal code. Later on, I will call this code as latent variables or latent space. And my key idea that I would like to deliver today is to utilize this the latent variables to produce appropriate output in the real applications. And by stacking on many layers inside of the encoder decoder, then anyway, we can extract quite sophisticated and interesting features with the latent variables. Or sometimes, if we do not have enough data, maybe we can cheat. In some sense, it's sort of the cheat to use the previous model trained with a lot of data for different application. Then we can just borrow the weight set to solve our problems at hand. That is called transfer learning. And also, why not increasing the number of data with generator model? So we can use generator and discriminator to generate or augment the new data set for the problem that we have to solve right now. So this is sort of the pieces that I can use for solving the problem. And there are many interesting applications already, right? For language processing, like constructing the chatbot, I mean the automatic mail respond program. How can you do? Maybe incoming the mails like, "Are you free tomorrow?" Maybe our program should provide the output. "Yes, what's up?" So those things can be implemented with encoder decoder architecture with the neural network. And near the same architecture can be used for image segmentation. So here, the input can be that color image, and by transforming the current image with the encoder and decoder, the output can produce the image, segmented image like this. Image segmentation is also quite important and interesting problem in image processing. It is possible. Even further, if we want provide the verbal description on that given image, how can you do? Maybe we can construct the encoder with that convolutional neural network, extract some features, and by using the sequence of the features to produce the sequence of words appropriate to describe that scene, then that kind of neural network can produce the output with this input. Actually, if we input this image, then the system can produce the output, a man flying through the air while riding a snowboard. Quite interesting, right? It is not constructed, it is not provided with the sophisticated algorithm. It is just generated with the combination of different neural network models. That was quite interesting. Even further, we can solve the problem of image generation by constructing the encoder to get the information about the text or statement, and we can construct the decoder to produce appropriate images. It is not just the retriever of the one of the stored image. It's just to try to generate the image like this. So the output can produce the output like the model can produce the output like this. So for the input on the bird has a yellow breast with gray features and a small beak. Then the system can produce the output like this. Of course, the generated images are not clear in some sense. However, still, in terms of the semantics, those images are quite in parallel with the text given. Quite interesting. And interestingly enough, by investigating inside of the latent variables, we can achieve quite interesting applications. Without any expressed input, we can just manipulate the latent variables like the smiling woman minus neutral woman plus neutral man. Then anyway, that latent variables can be represented and try to get the output. Then we can see the output is just smiling man. It was quite interesting. Algebraic operations can be possible inside of the latent variables. Actually, that is the idea. Latent space is sort of the internal variable in the neural network. And based on the manifold hypothesis, actual data set of interest lies in a space of a low dimension. Then maybe we'd better focus on a few key features of the data set to make decision. That is my idea. How can it do? Previously, in the field of neural network, already there are many different kind of models. The first one is autoencoder. Autoencoder doesn't give any interesting function. It can just produce the same output to the input. However, as I mentioned before, that inside of the code can be used for the representation of the original data. However, basically, these latent variables are constructed at random, which means that we cannot operate or manipulate these values on our purpose. So maybe we can use the modified version of autoencoder called Variational Autoencoder. The only difference is that we try to construct the encoder part with probabilistic way to construct the mean and standard deviation. It is sort of the restriction to the neural network. However, after constructing the neural network, we can use these mean and standard deviation to figure out the meaning of the latent variables like this. So by training the autoencoder with a variational way, then the internal variables can be figured out like this. And anyway, maybe internal variable of this part is for the digit 1, and maybe internal variable of this variable should be the digit 2. So those functionality can be decided later on. However, in this way, we need some trial and error to find the appropriate place where the data with desired feature are generated. It is not that promising. So maybe we can add the class label to control the characteristics of the data. Here, the decoder part, we can add the class label y to construct the probabilistic decoder. And by controlling these y variables, we can decide that we can construct the latent space as we want, like this. So we can see maybe the first row is mainly for digit 0, and second row is mainly digit for 1, etc. Even though maybe this is for the digit 5, but some area is for 8 and 6 or something like that. So it is not absolutely divided. However, still, we can control the latent space or latent variables a little bit. Even further, we can disentangle the latent variables for specific characteristics of the data. So for example, we can get some latent spaces at random like this. However, we would like to rearrange the latent variables with appropriate features that we want. So if we succeed, then maybe the latent variables can be identified with different styles in row and different categories in column. So maybe it is much easier to decide the functionality of the variables. So based on this background, our lab is trying to devise the interesting method to exploit the latent space. So currently, we have devised 3 different methods, like predefining the latent space in advance and transfer it to reuse for the application. Or we can construct the latent space with the non-Euclidean space, for example, the constant curvature manifold, and then train to regularize it to distinguish whether latent variable is in CCM or not. With these characteristics, we can solve some problems in anomaly detection. And third method is on the basis embedding on the latent space to extract appropriate coefficient for the basis element from the data and try to define the latent vector with their linear combination. So basic idea is based on encoder, decoder. Most of the deep learning models application can be achieved with this kind of architecture. And here we just devised the generative process with another neural network called regularizer. So by utilizing this model with some appropriate functionality, we can have many interesting applications possible. So I would like to skip the details on non-Euclidean latent space and basis models. And I would like to go on for the case studies. So my proposal today is to construct a deep learning neural networks like this, encoder, decoder, and positional regularizer to control the latent variables G. So with this architecture, by defining the characteristics of the additional regularizer, we can achieve many interesting systems. The first application is malware detection. You know, nowadays there are so many bad hackers to try to devise the more malicious software to invade the other systems or something. And manual detection is quite expensive. Also, every day the hacker try to devise a variant of the malware. So actually, there are so simple techniques like code interchange, null value insertion, reordering of subroutines can produce totally different the malware, which can be quite difficult to detect. And for this problem, we can devise the encoder to extract the features of the data into decomposed latent space according to the characteristics of the problem. And decoder try to restore the data from extracted features, and the regularizer is constructed to discriminate whether G is in predefined latent space or not. Quite simple formulation. With this formulation, we constructed a system with pre-processing, feature extraction, data generation, and finally learning. So this model was evaluated with the benchmark data. Actually, it is a little bit out of date, but Microsoft Malware Challenge was held in 2015, and this data set is opened in Kaggle. So this data set composed of 9 types of more than 10,000 malware data, each of which is represented in hexadecimal code in computer program. So we have to rescale these values into a 0 to 1. And these are the 9 different types of malware. So our problem is discriminate whether the current computer program belonging to one of the 9 different types. And as you see, most of the machine learning algorithms do not produce the satisfactory result. Nearly the 80% is the upper bound. However, using the deep learning models, most of them is more than 90%. And especially the proposed model produces the best result at the time. Of course, nowadays we implemented more advanced models, which is nearly the 99%. So after that, we analyzed the internal variables like this. So left side shows that the conventional neural network, actually the internal variables are quite mixed up with many different categories. However, after applying our proposed model, the latent space is clustered with quite an interesting way. And second application is on anomaly detection in video. So the problem is to find the novelty of unprecedented event or object in the video script. Nowadays, we can see many cameras in all over the world. Actually, every corner of the street in Korea, we can see some surveillance cameras. So I can see someone behind the camera is observing me. However, it is quite difficult to monitor all the different images at the same time. So anyway, we need some automatic system. So for example, this is the example of the pedestrian street. So left images, there's nothing significantly different. Many pedestrians just walking through the street. However, the right side, in the pedestrian street, a vehicle, maybe truck, is going. Maybe this is the abnormal situation, right? How can it detect this one? Is the problem. So we apply the same idea to construct the encoder to extract the features of data into a constant curvature manifold. Anyway, the everyday life is in Euclidean space, right? However, Euclidean is weird. Even however, the inside of the data space cannot be Euclidean, right? So anyway, we just would like to use constant curvature manifold to reconstruct the latent variables and try to classify whether the internal variable is in CCM or not to detect the abnormality, right? So in order to evaluate the system, we used 2 different benchmark data sets, the UCSD pedestrian 1 and pedestrian 2. So those are actually the same in pedestrian street, the images. However, the number of abnormal objects are different. The first one is the wheelchair, skate, bike, and vehicles are sometimes come up as an abnormal event. And the second one is only a skate, a bike, and vehicles are come up to show the abnormal object. And as I mentioned before, using that constant curvature manifold, interesting thing happened, right? So by using the architecture of the neural network, the normal data can be reconstructed clearly. However, the abnormal data, which was not appeared in training data, cannot be clearly reconstructed, a little bit blurred, right? So by looking at the difference of the original and constructed images, we can decide whether it is abnormal or not. So this is the real result. So the difference of the original and the reconstructed images, we can see the high difference or high. Then maybe these are the cases of the abnormal. How accurate it is? Fortunately, it was the most accurate compared with the state-of-the-art method at the time. I'm not sure right now, but at the time we just tried to compare the result of the proposed method with other 7 previous methods. And in most of the cases, our method was the best. And last application is the energy demand prediction. So nowadays, electric energy use increases according to the industrialization. So we need for efficient energy demand planning. In order to that, the first thing that we have to do is to predict the future demand on electricity. So the problem is quite demanding. However, the problem is also quite difficult. So this shows that the extracted features with Fourier transform quite complicated time series data. And also, even worse, the low correlation can be observed between the consumption and time. So we need more high-level prediction model. So we constructed the model of the encoder to extract the features of previous demand patterns, decoder to predict the future energy consumption, and the regularizer to analyze the latent space to produce the prediction. So this is the actual design of the system. The system utilized the latent space, and we also try to analyze the latent space with some technique. To evaluate the system, we also used the benchmark data in UCI database dataset, individual household electric power consumption dataset. It is weird and also huge size. So it is more than 2 million data collected for nearly three years. So input is energy consumption for 60 minutes, and output is the next energy demand for 15 minutes, 30 minutes, 45 minutes, and 60 minutes. So these are the attributes of each data item. And compared with other technique, other machine learning models, the error, actually this is y-axis is the error, is quite comparative for our proposed method. I'm sorry, the graphs are so small, but anyway, rightmost bar is produced by the proposed method. In all cases, the 15, 13, 30, 45, and 60-minute prediction, all the cases, the proposed method produces the best one. And as I mentioned before, by utilizing our method, we can analyze why this result came up. By analyzing the internal latent variables, right? So time's running up, so I just skip this part and try to summarize the talk. So anyway, today I would like to give the basic idea of deep learning and how to apply the models to solve the real-world computing problems. And especially I explained 3 different techniques like predefining, non-Euclidean space, and basis embedding for the 3 applications. So now I would like to conclude my talk with some discussion on the pros and cons of deep learning. Of course, the deep learning is quite powerful. It is easy to construct the computative solution in the limited environment. What we have to do is just collect the data and train the model. And finally, we just evaluate the performance of the model. That's all. So even for the novice people who do not have any enough knowledge on computer science or computer software, still can produce the computative result. However, it is quite difficult to specify what is going on inside of the neural network. And also, we have quite difficulty to use the known knowledge in the domain. So there is quite a critical problem. And basically, frankly speaking, that even though the performance is amazing, the functionality is quite limited because that these models are working only on limited environment. That is similar to the training data. If the new data is totally different from the previous trained one, then unfortunately this model cannot work on. Okay, that's all for today's talk, and I'm happy if you to answer the question if you have any. Okay, thank you for your attention.